Hi everyone, this will be your video for derivatives using the limit definition. So when we're looking at this is our main idea here. We're going to break this down and kind of recall some of the information from last week. So when we're looking here, we have f prime of x. So right here I'm looking at f prime of x. So what that's telling me is that's notation is telling me this is the derivative. So there's a couple different notations that all mean the same thing. So obviously this f prime of x. We also have y prime. You could also have dy dx or d dx. So all of these are all notation, which all means the same thing. Okay, so all mean derivative. Okay, so all of these mean the same thing. So we have our derivative notation here, so it's saying that the derivative of f, right, so because this is our function f prime means the derivative of f is, so we have the limit as delta x is approaching 0. You're also going to see this with an h in place of delta x, and just keep in mind delta x is like one variable. It's not like something nx or a value of x. It's just like one variable. So delta x is talking about the change in x, and our idea is to get the change in x really tiny, really close to 0. So that's why we're taking the limit as the change in x is approaching 0. So what we need to do mathematically or algebraically, we need to take our function and we're going to plug in x plus delta x to our function. Just kind of like make this new function up here. Then we're going to subtract our original and we're going to divide it all by delta x. So I'm going to write it also in the notation that you'll see on delta math. Okay, it's the same process, just slightly different. So you're going to see f prime of x equals, and then it's going to be the limit as h approaches 0 of x plus h minus f of x all over h. So you can see it's very, very similar. It's just the only difference is that you have an h in place of delta x. So let's use this idea. So when we're looking at this function here, we have f of x equals negative 3x squared plus 4. So our goal right now is to find f of x plus h and then use those two functions in our limit definition. So it's nice to kind of get it set up like on the side a little bit ahead of time and then use all your pieces. So if I'm trying to find f of x plus h, that just means everywhere I had an x, I'm going to replace it with x plus h. So I have negative 3 x plus h squared plus 4. So now I'm just going to make sure I can simplify this. This has to be FOILed. So this is negative 3 times, and when I FOIL this x plus h, becomes x squared plus 2xh plus h squared plus 4. And then you can simplify even further. So we have negative 3x squared minus 6xh minus 3h squared minus 12. So we have our two functions now, our two pieces that we need. We have our f of x and f of x plus h. So we're going to use this in our limit definition, and sometimes it's nice to just keep rewriting it until you remember it. So we have the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so let's get this set up with our actual values now. So we're going to have the limit as h approaches 0. Now we already know our f of x plus h, so I can write that out. So it's going to be negative 3x squared minus 6xh minus 3h squared minus 12. And then we're going to subtract our f of x function. It is so important that you use parentheses here because you need to make sure you're subtracting all of your terms from that f of x function. So we have negative 3x squared plus 4. And this is all over h. So if you have a problem that says get this set up and you don't need to simplify, This would be an appropriate step. You can even do it without having to FOIL here. Like this would have been an appropriate replacement here. But when you are working on these problems either on paper or on some of your assignments, you need to complete this totally, and we're going to find a value, and we're going to do that in one of our later examples. But for now, if you're having a problem that says just to set this up in your limit notation, this would be your solution here. So here you can see an example completely done out. Not only are we finding the setup for the limit definition, but in this example that you see, you'll also see that we'll end up with a solution. We'll actually have our derivative. So our first step is always to make sure that we can find our f of x plus h. We're going to need that in our problem, so it's nice to just get it out of the way. And then here I have my limit definition just written again. So here's my setup. So I have my f of x plus h minus my f of x over h. Now the problem with this, when you have a radical sign, and even if you have two radical signs, sometimes when you plug in that h, you end up with a 0 over 0, right? So we know that we need to do our rationalization technique. This was from our analytical limits week. So we have our rationalization, which means that we just take whatever these radicals were. We're going to change this operation in the middle. So it was subtraction, now it's addition. And we're going to multiply across. So you can FOIL your numerator. I would not suggest distributing your denominator, and you'll see why. And that's because we hope that this is going to cancel out. So we have our numerator FOILed. We have our denominator just written, not distributed. Okay, h is still in the front. As you're going through, you just want to keep simplifying what you can. So we have, let's see, we have our 4x and all of this. The 4x and the 4x cancel. The 5 and the 5 cancel. So you're left with 4h over h times this rest of our denominator. So this h in my numerator, h in my denominator, they'll both cancel. And that's really what you want here. You're kind of trying to find a way to rewrite. So we want it to cancel, and when it does, and I've scrolled up a little bit here, so when it does, you can see that now you can plug in that h. So we can plug in our 0 for h, and you would plug it in anywhere you see it. We just have it in one spot right now. And when we do, you can see we can simplify, and your answer is going to have an x in it. Your answer will look like another function, and that's okay. The only times that this wouldn't happen is if they give you a value for x, you would plug that in, and then you'll end up with a value.